I started a project here to troubleshoot and try and fix this keyboard that's giving me problems. This is an 8032 business keyboard. Only a few of the keys work. The rest of them are really stubborn, and no matter how hard or how often I press them, they're not giving me any reading. So what I wanted to do is figure out if they're making a connection and what the resistance is across that connection when I press the key. So I've gone through and I've toned out the cable completely. So we're connected to pin 9 right now, and we should have less than half an ohm. Oh, we've got 0.6 ohms just through the cable. That's from the connector to the end of the cable. And if we're looking at the space bar, which should be across these two pins, if I press the space bar down, we're getting a little over 200 ohms, 250 ohms. Okay, so I know that the R and the T key were working. If I press the T key, I'm getting 500 ohms. Seems pretty high. And the R key is one pin over. R, 1.4 k ohms. 1.3 k ohms. According to the keyboard matrix reference that I'm using, the A key should be here, but I'm not getting anything. Let's try Q. Q key should be here. We are reading. But that looks like 60 to 70 k ohms. This should be the G key, but like the A key, I'm not reading anything at all. This row here, I'm getting about 10 k ohms on the keypad 6 key. But the other keys that are supposed to be along here are reading open. The at, the L key, the return key, I'm reading nothing. I'm not sure why, unless the pads are open or something like that. So here we are with the known good keyboard. I've connected up to the matrix for the spacebar. Pressing the spacebar, we're getting about 10 ohms. Trying out the return key, getting 20 ohms. Z key, 60 ohms. C, 25. B, 10. M, 17. So it looks like most of these are below 30 ohms. So, 500 or a kilo ohm is a bit too high. So let's see what we can do about the other keyboard. I think I figured out why a lot of these keys aren't working. I was troubleshooting the return key, basically most of the keys along this middle row. The return key should be connected here to pin 4, but it's not. So I trace pin 4, I have continuity here. And then it comes through one of these weird jumpers. This is a jumper over some of these other traces, and scraping off some of the solder mask there, I have continuity through that jumper. And coming over here, I have continuity to here, but this jumper is open. I don't have any continuity here. This pad, got continuity here from this end of the jumper back to this trace where it's supposed to be, but nothing right here. Got good continuity from this end of the jumper all the way back over here to this board and to pin 4. And I have good continuity from this end of the jumper back here all the way to the return key. But there's no continuity across this jumper. Nothing. this copper strip runs over the top of these other traces and is insulated, so it's just jumping over these traces. It's kind of a cheap way to do it, but something happened in the shipment of this keyboard, and right about here, I'll insert a close-up photo, there's a break, a crack in this plastic, acrylic, whatever this material is that this copper strip is embedded in, has cracked, and it has broken this copper strip. So I'm going to try to repair it. First thing I need to do is scrape away the solder mask or the insulation on top of this copper strip, and then I'll see if I can bridge that crack. Well, clearly that copper is not very thick. Right about here is where the gap was, where the crack is. I was trying to scrape away just the insulation, and I ended up scraping away the copper. So I'm just going to have to be a little bit more careful and find some way to strip the insulation off of it, or I may just have to run a complete wire jumper. Well, this is a lot harder than I thought. Trying to remove the insulation is just removing the copper. I ended up using some very fine sanding bars, 3200 grit and one that's just labeled fine. And even just using the sanding grit took out some of the copper right here, right in this area here. This was the result of scraping, and this was just from the sanding. So that copper strip there is extremely thin. I started with a small piece of Kapton tape right here across these traces to insulate them. Then I'll place a small piece of copper tape across this gap. So now I'm just going to tack a little bit of solder on either end here to electrically connect those. I've applied a very small amount of liquid flux to the copper tape and the trace on either side there. And got my magnifying viewer on. I'm going to try to add a little solder bridge, and the trace is just burning off. Nope, I'm not going to be able to solder to it. So I'm going to try this again. Put down some new Kapton tape to insulate across these traces. And I'm going to try to run some copper tape all the way from this pad to this pad instead of just trying to bridge the gap. Okay, I've got the copper tape in place. I'm going to try to create a solder bridge here and here to make the electrical connection. So I'm trying to put the tiniest drop of liquid flux right here on this pad. And this one. I messed up recording that. I hit stop instead of start. But after I put the flux on there, put a tiny drop of solder on the end of the iron and tried to bridge the caps here and here. And it looks like I did it. We're connected to the copper pad here and here visually. Touching the pad here. I'm going to go around to here. We're good. If we have continuity between here and pin 4, then we've succeeded. Pin 4 and the return key, we're good. And I'm just going to clean that flux off. And there's the bridge. Now I guess I can get back to the rest of my testing. Hopefully none of these other bridges are broken. There's so many of these bridges on this board. When we last left off, I was attempting to figure out what the resistance was across these pads with these carbon pads here. The problem with these carbon pads, I don't know if that's a problem, but they're floating. They're on a piece of rubber. So if you push down on these hard, you're not pushing harder on the carbon pad, you're pushing harder on the lip around it. So you can only get a certain amount of pressure on these pads. Enter. That's 12, that's kiloohms. That's pretty high. So I want to try something here. I'm going to take this pad that we were just measuring about 9 kiloohms on. I'm just going to try a little abrasion on it, on the copper pad. This is a pretty fine 3200 grit. I'm just going to lightly buff that copper pad just to take off a little bit. We don't want to use anything too coarse because I don't want to take off all the carbon. And then we'll see if the resistance improves any. It looks like mega ohms. I'm getting it centered here. We're down to 4K. Clean the pad with a little bit of isopro. And see if that improves anything. Maybe I'll clean this pad with a little bit of isopro too. And we're under 200 ohms. I'll take that. I'm going to try burnishing the copper on the pad here. This is a fine stick. It doesn't say what it is, but it definitely feels finer than the 3200. I'm just going to buff it a little bit, shine it up. Visually I can tell it's doing something because it definitely visually shines it up. Use a cotton swab with a little bit of isopro to make sure we get any grit that's on there. This has been cleaned with isopro and buffed. A, B, C, D, E. And try again. 120 ohms. That's probably about the best we're going to get, and I'd be surprised if that didn't work. So I'm going to do this to all the pads and all of the carbon pads, and I'll put the keyboard back together and see if it works. It's tedious and it's time consuming, and I've gone through and wrung out continuity on every pin to every pad that it should connect to. So I'm satisfied now that there aren't any more breaks, unless it happens to coincide with the flexing of the board. Everything's good. I've polished all of the copper pads and cleaned them with isopro. So now we're going to work on the carbon pads. Light polish. And I'll just clean each one with a little isopro on a cotton swab. Numpad down, all these keys left to go. So I've polished every one of those carbon pads and cleaned every one of them. The cotton swab got kind of dark. With all of the carbon pads cleaned and polished, there's nothing left to do now but put it back together and test it. When I press the enter key, we should get a reading. And we're in the 60 ohm range, less than 100 ohms. I'm happy with that. Move over to D. And we should get J. That's a kiloohm. 800 ohms, 700 ohms. Great. Move over one, we should get G. It's in the 200 ohm range. Next to G is D. That's in the kiloohm range. And one over, should be reading A. 32, oh, that's in a 30 kilo ohm range. So this will be interesting to see if the A key does not work and the others do. I'll plug it into the computer and see what happens. See if the A key works. A key does not work. S does, D, F, G, Q does not work. W does not work. E, R, T. 0, 9, 8, 7 is flaky. 6, 5, 4, 3. I'm gonna have to polish these pads a little bit more. But it confirms my theory. The enter key works fine. Less than 100 ohms. The A key, well over a kilo ohm. I think that was 30 kilo ohms, and we're not going to get anything from the A key. Well, the A key wasn't working, so I took the keyboard apart again, and I buffed the carbon pad on that A key a little bit more, and it went from 30k ohms down to under 100 ohms. So that should work. I'm going to test the rest of the keys like this before I put it all back together and test it again. The W key was giving us problems too. 9 kilo ohms. I've rebuffed most of these pads and have been very careful not to touch any of them again. And I've also rebuffed the carbon contacts for all of the keys that were giving me trouble, and I'm being very careful not to touch any of these again. I'll put it back together and try testing again. So we got the bottom screwed back on mostly. I'm going to check some of the keys that were giving me problems. The A key was the problem before. That's down to less than 200 ohms. Checking a few other keys on the same pin. The D key. D is 800 ohms, 700 ohms. I think that's sufficient for it to work, but we'll make a note of that when we're testing. And the G key is the next one over on this pin. 400 ohms. J is a kilo ohm, and it was working before. 1.2k ohms. So that still may be sufficient for it to work. Be interesting to see that. Final test of the keyboard, hopefully. In testing all the keys with the meter, I got anywhere from 50 ohms to 1.5k ohms. Cursor key works. Run stop key makes the cursor flicker. Tab key works. Cursor up, cursor down. Delete. Escape key causes the cursor to flicker. Enter key works. Reverse key. Shift reverse. And the shift key over here. And the repeat key. And the numpad. And the clear home key. Looks like it all works. Keyboard's good to go. There's a few keys that are a little flaky, but I really don't want to take it apart again. Thanks for watching.